Hi everybody, welcome to a new lecture of ITC 255 where we start discussing different types of probability distributions. Based on whether a given random variable is continuous or discrete, we have different types of discrete or continuous probability distributions. Please remember that the distributions that we are discussing in the following are theoretical distributions but models different distributions of different variables in real world, such as age, height, income, GPA, passing or failing a test, and so on and so forth. We start with discrete probability distributions. And the first distribution that we discuss is Bernoulli distribution. To that end, we first introduce Bernoulli experiments. Consider a random experiment which has two possible outcomes such as 0 or 1, passing or failing, arriving on time or late, technical failure yes or no, female or male, and so on and so forth. Such experiments are called Bernoulli experiments. To model such experiments, we use a random variable which is defined from 0 and 1 to 0 and 1 with the following probability distribution. Probability that x is 1 is p, and probability that x is 0 is obviously 1 minus p. Remember that p is a number in the closed interval 0 and 1. Most of the times, p is also referred to as a success probability, while 1 minus p, which is most of the time people call it q, is the probability of failure. The variable x with such distribution, with such probability distribution, is said to have Bernoulli distribution. After some basic calculations, we can find that the expectation of x is p and the variance of x is p times 1 minus p. The next discrete probability distribution is binomial distribution. Now, binomial distribution is very much related or based on Bernoulli experiment, in the sense that if we repeat a Bernoulli experiment more than one times, we get a distribution of outcomes to which we refer to as binomial distribution. Let's consider a random variable x which presents the number of ones or the number of successes in n Bernoulli experiments. Hence, x can take values in 0, 1, 2, or n. That means if we get no 1 or no success in n tries, the value of x is 0. If we get one success, the value of x is 1, and so on and so forth. Then x obviously has a discrete distribution with the following probability mass or probability distribution function. Probability of x is equal to f of x, which is the combination of x over n, p to the power x, q to the power of n minus x, where x is obviously the number of successes, 0, 1 up to n, p is the probability of getting 1 or success, and q, which is minus p, is the probability of failure or getting 0. X has binomial distribution with n, p, and q, where the n, p, and q are the parameters of the distribution. Recall that x over n is equal to n factorial divided by x factorial times n minus x factorial. For example, consider the experiment of observing the gender of the next customer coming to your shop. Furthermore, suppose that you have used the initial probability of getting a female is equal to getting a male is equal to 50%. And repeat this experiment 5 times. Let x be the number of females. Then x can take any value between 0, 1, 2, 3, 4, and 5. Then the probability of getting, for example, 3 females out of 5 is f of 3, which is probability of x equals to 3, which is 5 over 3 times 0.5 to the power of 3, and times 0.5 to the power of 2. After simplifying this expression, we get 0.3125. That means getting 3 females out of 5 customers has the probability of nearly 31%.